Friends, welcome to Toral Education on the digital class platform. Myself, H.V. Kevadia, and I am teaching you today the lesson number 3. Here, we can summarize that the lines may intersect in a point and the pair of equations has a unique solution. That is the consistent pair of equations, right? Lines intersect in a point. That is unique solution. The lines may be parallel and the pair of equations has no solution. That is inconsistent pair of equation. We can say inconsistent pair of equation. If the lines are parallel, the lines may be coincident and the pair of equations has infinitely many solutions. If both the lines are of same, that is the single line represent the two equations, then it is coincident line and this has infinitely many solutions. It is also dependent pair of equation, or we can say consistent. If unique solution, then consistent. If infinitely many solutions, then consistent. In short, if the pair of equations has solution, then it is consistent, and if it is parallel, there is no solution, then it is inconsistent. This must be cleared before going ahead. Now look at the equations. Here are the two equations, a1x plus b1y plus c1 equals to 0 and a2x plus b2y plus c2 equals to 0. These are the two equations. If a1 upon a2 is not equals to b1 upon b2, then the lines are intersecting and have unique solution. Remember these green formulas, that is the formulas given in the green background. Here solutions have unique solution if a1 upon a2 is not equals to b1 upon b2. If a1 upon a2 equals to b1 upon b2 equals to c1 upon c2, this one a1 upon a2 equals to b1 upon b2 equals to c1 upon c2, then the lines are coincident and have infinitely many solutions. They have infinitely many solutions. That means both the equations represent the single line. And if a1 upon a2 equals to b1 upon b2 but not equals to c1 upon c2, then the lines are parallel and have no solution. They do not have any solution. So remember these things. We will have to solve these equations. We will have to tell whether they are consistent or not. So the first question in exercise 3.2, form the pair of linear equations in the following problems and find their solutions graphically. Here also it is given graphically. Let the number of boys, here I am reading the question. 10 students of class 10 took part in the mathematical quiz. If the number of girls is 4 more than that of number of boys, find the number of boys and girls who took part in the quiz. So let the number of boys be x and number of girls be y. We should have to take x and y as variables. Total number of students are 10. So number of boys plus number of girls equals to 10. That is x plus y equals to 10. This is equation number 1. But number of girls are 4 more than the boys. So we can say if we add 4 in the boys, then both the numbers are equal. That is x plus 4. Boys are x. If we add 4 in x, then we get number of girls, that is y. Right? X plus 4 equals to y. We can say like this. X minus y equals to minus 4. Y has been taken to the left side and 4 to the right side. So this is equation number 2. You should draw the graph in your graph paper. And now question number 2. 5 pencils and 7 pens together cost rupees 50, whereas 7 pencils and 5 pens together cost rupees 46. Find the cost of one pencil and that of one pen. So here let the cost of one pencil be x and that of one pen be y. Right? So 5 pencils and 7 pens cost together for rupees 50. Here 5x plus 7y equals to 50. Because 5 pencils means 5x and 7 pens cost means 7y, that is 50 rupees. And 7 pencils and 5 pens together cost rupees 46. We have to take 7 into x, that is 7 into pencils, and 5 into pens, that is y, that is 7x plus 5y equals to 46. The total cost is 46. So here are two equations and you should draw the graph in your graph paper. Now question number 2. Here question number 2 and question number 3, these are the same questions, but look at here. On comparing the ratios a1 upon a2, b1 upon b2, c1 upon c2, find out whether the lines representing the following pairs of linear equations intersect at a point are parallel or coincident. We have to decide. 5x, the first equation, 5x minus 4y plus 8 equals to 0. This is in standard form, you know. And 7x plus 6y minus 9 equals to 0. This is a1x plus b1y plus c1 equals to 0. And a2x plus b2y plus c2 equals to 0. So, if we take a1 upon a2, then 5 upon 7. This is 5 upon 7. If we take b1 upon b2, that is minus 4 upon 6. Minus 4 upon 6 gives us minus 2 upon 3, because 2 to the 4 and 3 to the 6. Here is the b1 upon b2. So, this 5 upon 7 and this is minus 2 upon 3. Both are not equal. So, a1 upon a2 is not equal to b1 upon b2. And therefore, the linear equations intersect at a point. Question number 2. 9x plus 3y plus 12 equals to 0 and 18x plus 6y plus 24 equals to 0. So here we will see a1 upon a2, that is 9 upon 18. 9 upon 18 means 1 upon 2. b1 upon b2, that is 3 upon 6. Look at this, 3 upon 6, that is 1 upon 2, because 3 to the 6, 9 to the 18. And c1 upon c2, 12 upon 24, that is 1 upon 2. All these are equal. So a1 upon a2 equals to b1 upon b2 equals to c1 upon c2. So the linear equations are coincident, means have infinitely many solutions. Both the lines are same, so they have infinitely many solutions. Question number 3. Here 6x minus 3y plus 10 equals to 0 and 2x minus y plus 9 equals to 0. So a1 upon a2 equals to 6 upon 2. 6 upon 2, that is 3 upon 1. b1 upon b2 equals to minus 3 upon minus 1. Both are minus, then it is positive. 3 upon 2, 3 upon 1, sorry. And c1 upon c2, that is 10 upon 9. 10 upon 9. Here a1 upon a2 equals to b1 upon b2, but not equals to c1 upon c2. Therefore, the lines are parallel and have no solution. Question number 3. Now we will see question number 3. What is written here? On comparing the ratios a1 upon a2, b1 upon b2, c1 upon c2, find out whether the following pairs of linear equations are consistent or inconsistent. Consistent means they have solution, whether a unique solution or infinitely many, but they are consistent. And inconsistent means they are parallel, that means the lines are parallel. Here are two equations, 3x plus 2y minus 5 equals to 0 and 2x minus 3y minus 7 equals to 0. So a1 upon a2, that is 3 upon 2, b1 upon b2, that is 2 upon minus 3. Here we have got the answer. If a1 upon a2 is not equals to b1 upon b2, then they are consistent. They have unique solution. Now, number 2, 2x minus 3y minus 8 equals to 0 and 4x minus 6y minus 9 equals to 0. If we take a1 upon a2, then 2 upon 4, we get 1 upon 2 because 2 to the 4. b1 upon b2 that is minus 3 upon minus 6. So 1 upon 2 and c1 upon c2 minus 8 upon minus 9 that is 8 upon 9. If we get a1 upon a2 and b1 upon b2 that is equal, if we get these both equal, then we have to take c1 upon c2. Otherwise there is no need of taking c1 upon c2. We have taken here only two things, a1 upon a2 and b1 upon b2. We got not equal, that means they are consistent. If we get both are equal, then we have to take c1 upon c2. Okay, so a1 upon a2 is not equals to b1 upon b2 is not equals to is equals to b1 upon b2 is not equals to c1 upon c2, that is they are inconsistent. These lines are parallel. Now question number 3, 3 by 2 x plus 5 by 3 y minus 7 equals to 0 and 9x minus 10y minus 14 equals to 0. Here 9x plus 10y minus 42, because 6 is LCM and 3 3s are 9, 2 5s are 10 and 7 6s are 42 equals to 0. Here the same equation. If we get a1 upon a2 that is 1 upon 1 and b1 upon b2 that is 1 upon minus 1. Look, 9 upon 9 that is 1 upon 1 and 10 upon 10 minus 10 that is 1 upon minus 1. Here a1 upon a2 is not equals to b1 upon b2. So they are consistent. We can write in this way. Now 4 number, 5x minus 3y minus 11 equals to 0. Minus 11 equals to 0 and minus 10x plus 6y plus 22 equals to 0. Right? Here is given plus 11 and I have taken here in the standard form. In this equation also I have taken 22 as C in the standard form. So a1 upon a2 5 upon minus 10, this 5 upon minus 10 that is minus 1 upon 2, minus 3 upon 6 b1 upon b2 that is minus 1 upon 2 and c1 minus 11 plus 22 that is minus 1 upon 2. If a1 upon a2 equals to b1 upon b2 equals to c1 upon c2, then they are consistent. They have infinitely many solutions. Question number 5. Four upon 3 x plus 2y minus 8 equals to 0. 2x plus 3y minus 12 equals to 0. Here it is 4 upon 3. So we have to take LCM first. So LCM is 3. 3 will be multiplied with 2 and minus 8. So 4x, this is 4x plus 2 3s are 6y minus 24 equals to 0. Then here the same equation, a1 upon a2 that is 4 upon 2 that is 2 upon 1, 2 2s are 4, 2 1s are 2, 6 upon 3 b1 upon b2, 2 upon 1 and again c1 upon c2 that is minus 24 upon minus 12. This is minus 24 minus 12. So 2 upon 1. Here a1 upon a2 equals to b1 upon b2 equals to c1 upon c2. Therefore they are consistent. Right? Question number 4 is written, which of the following pairs of linear equations are consistent or inconsistent? If consistent, obtain the solution graphically. I have not drawn graph, you know very well. Right? Graph should be drawn by your own in the graph paper. Here there is no graph paper in the desktop. So here question number 1 in 4, x plus y minus 5, x plus y minus 5 equals to 0 and 2x plus 2y minus 10 equals to 0. From this we can take x plus y minus 5 equals to 0, dividing by 2. If we divide this equation by 2, we will get this x plus y minus 5. 2 1s are 2, 2 1s are 2 and 2 5s are 10. You can see here both the equations are equal. So a1 upon a2 equals to 1 upon 1, b1 upon b2 equals to 1 upon 1, c1 upon c2 equals to 1 upon 1. Therefore, all are equal, then they are consistent. All are equal means both the lines are same. X minus y minus 8 equals to 0 and 3x minus 3y minus 16 equals to 0. We can say a1 upon a2 1 upon 3. Here is 1. If there is no coefficient, then 1 is the coefficient of the equation of the variable upon 3. Minus 1 upon minus 3, that is 1 upon 3. And c1 upon c2 minus 8 upon minus 16, that is 1 upon 2. 8 to the 16 and minus minus plus. Here also minus minus plus. So we have got a1 upon a2 equals to b1 upon b2, but not equals to c1 upon c2. So they are inconsistent. Remember these three conditions. Number 3, 2x plus y minus 6 equals to 0 and 4x minus 2y minus 4 equals to 0. Take a1 upon a2, that is 2 upon 4. We get 1 upon 2 because 2 to the 4. b1 upon b2, we get 1 upon minus 2. Here y has 1 and this y has minus 2. 1 upon minus 2. So these both are not equal. So we should not take c1 upon c2. Here a1 upon a2 is equals to b1 is not equals to b1 upon b2. Therefore they are consistent. 2x minus 2y minus 2 equals to 0 and 4x minus 4y minus 5 equals to 0. So we have here a1 upon a2, 2 upon 4, this 2 and this 4, 1 upon 2, minus 2 upon minus 4, that is also 1 upon 2, and c1 upon c2 minus 2 upon minus 5, that is 2 upon 5. So the same condition, a1 upon a2 is not equal is equals to b1 upon b2 is not equals to c1 upon c2. Therefore they are inconsistent. Remember these things. I tell you again and again. Question number 5. Let me read the question. Half the perimeter of a rectangular garden whose length is 4 meter more than its width is 36 meter. Find the dimensions of the garden. Find the dimensions. We have to find the length and breadth. So let the length of the garden be x meter and breadth be y meter. Length is 4 meter more than breadth. So we can say x is 4 meter more than y. Therefore x equals to y plus 4. If we take y to the left side, it will be negative x minus y equals to 4. This is equation number 1. Now you will see half the perimeter. Do you know the formula of perimeter of rectangle? 2 into L plus B. But half means 1 upon 2 into 2 into L plus B is 36. So 2 and 2 will be cut off. L plus B equals to 36. L means x and B means y equals to 36. Now when you draw the graph of these two equations, you will get intersecting line and the intersecting point is your answer. X coordinate first and y coordinate later. Question number 6. Given the linear equation 2x plus 3y minus 8 equals to 0, write another linear equation in two variables such that the geometrical representation of the pair so formed is intersecting lines, parallel lines and coincident lines. We are given here 2x plus 3y minus 8 equals to 0. So we will have to check a1 upon a2 is not equals to b1 upon b2. Such equation is to be written that both the perimeters are not equal. We know that this is not equals to this, then the lines are intersecting and have unique solution. Right? The first condition is unique solution, intersecting lines. The possible equation for the condition is 3x plus 2y minus 7 equals to 0. We can write any equation except these two must not be equal. That is 2 upon 3. A1 upon A2. 2 upon 3. Check. 2 upon 3. B1 upon B2. 3 upon 2. 2 upon 3 is not equals to 3 upon 2. Therefore, A1 upon A2 is not equals to B1 upon B2. We have this equation. Second condition is parallel lines. Parallel, we know that A1 upon A2 is not equals to B1 upon B2 is not A1 upon A2 equals to B1 upon B2 is not equals to C1 upon C2. Then the lines are parallel and have no solution. The possible equation is, here is equation 2x plus 3y minus 8. So we will write 2x plus 3y. We can also write 4x plus 6y. We can also write minus 2x minus 3y. Okay, but is not equals to C1 upon C2. Minus 8 upon minus 12. So 4 2s are 8 and 4 3s are 12. So it will be 2 upon 3. This is 2 upon 2. This is 3 upon 3 and this will be 2 upon 3. So both the condition, this condition is followed here. So this is our equation. And third condition, coincident line. Coincident line means A1 upon A2 equals to B1 upon B2 equals to C1 upon C2 must be there. So we have to write 2x plus 3y minus 8. The same equation 4x plus 6y minus 16. Look at this. A1 2 upon A2 4. 2 upon 4 that is 1 upon 2. A2 3 B1 3 B2 6. So B1 upon B2 3 upon 6 that is 1 upon 2. C1 minus 8 and C2 minus 16. So minus 8 upon minus 16 that is 1 upon 2. So we have got this condition. Now question number 7. Draw graphs of this equation and solve. Here draw the graph of equation x minus y plus 1 equals to 0 and 3x plus 2y minus 12 equals to 0. Determine the coordinates of vertices of the triangle formed by these lines and the x-axis and shade the triangular region. You have to shade the triangular region when you draw the graph, right? When the lines intersect, you will get two lines and two lines will be intersected. They form a triangular region with x-axis. Now, if the triangular region is obtained, you should shade the triangular region with your pencil. This is the end of exercise 3.2 and we have completed this. Thank you for being with us. Thank you for subscribing digital class and thanks again for watching the video. Thank you very much.